That's right. If you were wanting to title the next set of notes, we're going to have probably two sections of notes left. We're going to have area and we're going to have volume. Last two things, learning no new skills, so we're still going to be integrating. It's just we're going to be applying these in a little different way. And I know we have talked about in the past that integration is area. It is. It's the area between the curve and the x-axis. When we're talking about area now, our goal is to be able to take an irregularly shaped object and find the area of it. That's our goal. How can we find the area of an irregularly shaped object? So that's where we're headed with all of this. This is our first problem, and it's really kind of a review problem, but I want to kind of lead up to where we're going and kind of give you some good skills, I think, on trying to solve these type problems. So if you look at the first problem, and this is typically the way that you would see problems laid out from a math perspective. Find the area of the region bounded by the graphs of the following curves, and we'll give you 4 curves. Now, something that you probably don't remember, or if you do, you may forget from time to time, y equals 0 is the same as saying the x-axis. And x equals 0 is the same as saying the y-axis. So I always think that it's best when I've got a picture. If I don't have a picture, I try to draw a picture. If I do have a picture, I try to color in the area that I'm trying to find here. So we're wanting between these 4 regions here. So we're going to be talking about this area right here that I'm shading in. Bless you. So that's the area that we're trying to find. Now, based on that, you already know how to find the area of this, because this is very much like what we were doing before when we were kind of taking baby steps towards this. If we're wanting to find that area, we're going to integrate from 0 to 2 of x cubed plus 4 dx. Now, I want us to take a minute and review and break down where these numbers come from, because I have found that if students can start getting it ingrained in their head now, where all these numbers came from, it just makes it easier, because we're about to turn things sideways and add other things to it that just sometimes make it intriguing to try to figure out. So, where did we get the 0 and the 2 from? These given values here. We're going from x equals 0 to x equals 2, and notice that our variable that we are integrating with respect to is x. So all of these numbers, the 2, the 0, the dx, and what we're integrating are all related to x. That's important to remember. Anytime you're integrating, if you're integrating with respect to x, then your limits of integration are x numbers. Is the order of the 0 and 2 important? Yes. Which one do we want where always? Bigger one on top. And when we actually evaluate this, if we go ahead and evaluate this, we'll get x to the 4th over 4 plus 4x, and we'll evaluate it at 0 and 2. Bless you. And that will give us 2 to the 4th is 16 over 4 plus 8 minus 0 plus 0. So that's going to give us what, 12? All right, so we get an answer of 12. Remember that when we're subtracting them, they're always top minus bottom. The top limit of integration minus the bottom limit of integration. Yes, ma'am. Yes, you may. So all of this is just review of what we've done before. Nothing new here. Okay, let's look at the next problem and tell me how this is different? Okay. All right. So, but before we go with that Sarah Beth said, which is right, do you have a question that I need to?
Why don't you integrate the y equals part of it?
We're just integrating the function. Integration is part of an equation. So it would be area equals this thing here. Integrating y equals something doesn't make sense. We'd have to integrate both sides of it there. You're thinking more about differential equations. If we had started with a dy dx, then we would need to integrate both sides of it. But we don't have that. We've just got y equals. Okay. Does that clear things up for you some, sir?
I guess.
All right. Now, when you look at this next problem, you notice everything is the same except one thing. Except this y equals negative x. So let's start off looking at our region over here. How is our region different than it was before? It goes below the x-axis. It goes to the left side of the y-axis. Does it? No. Why not? Okay. It says 0 to 2 for the x's. So we're talking about from this blue line here to this green line here. And then we're talking about from the red curve down to the kind of purplish line that I've got up here. So should this area be bigger or smaller than the other one? Bigger. Okay? Does everybody agree that our answer here numerically should be larger? Well, now let me ask you something. What did we just learn about, or before today, if I said integration and we've got some area below the x-axis, it should be, we've been thinking of that area below as negative, haven't we? Right? Because and remember, this is where it's a slight nuance. What does the negativeness of the area mean? Go back to the FRQ that's due tomorrow. You know, one part of that area that you found was negative. What does that negativeness mean? Does anybody remember? We're subtracting it, and it's if you think about integrating, if we integrate a function from 0 to 1, if we were to integrate that's negative x from 0 to 1, that's really telling us the change from 0 to 1 is negative. The value of this new function out here is getting smaller. But now when we're trying to find the actual area of something here, do we want to thinking about this logically, do we want to think of this area down here as negative or not? When we're trying to find the actual area. I mean, it's got to be bigger. When we add this triangle onto it, the area has to be more than what it was before. Would you agree with that? So it should be this area that we got before, which we found this area a while ago to be 12. It's got to be 12 plus whatever that is there, which is going to be 2, I think. Yes, sir. Y equals 0. But this part of the area down here should be negative.
Well, why would we think of it as negative at all if we are bounded by? Shouldn't we think of anything below y equals negative x as negative now instead of y equals?
Okay, that's where I was trying to head to there. Yes. Okay. Yeah. You're a step ahead of me, but yes, you're right there. Okay. So let me see if I can throw you for a loop here. And kind of tie into what he was saying there. Think about this shape here, okay? If I were to take that shape and move it over to the second quadrant, the second quadrant, would the area still be the same? Isn't the area always the same? Just like pi is the same even on the moon? Okay. But if I move this shape to the fourth quadrant, or the third, or the second, the area of it should be the same. If I bring it out here in the middle of the room, the area should be the same. I mean, just logically that makes sense, right? So we need to figure out how can we mathematically, is there a way we can come up with mathematically to say, this is how to find the area every time, and we don't have to think about where it is in the plane. Possibly you could do that, but let's look at this example right here. With here, we know we need to take this area, 12, and this area down here, which I figured out in my head because it's a triangle, to be 2, and we need to add those two together. Agree? So it's almost kind of like we need to take absolute values of different pieces. Would you agree with that? Like if we took, if we could think of it this way. We could take the area that's above the x-axis, take the absolute value of it, you know it's going to be positive. Take the area of anything below the x-axis, take the absolute value of it, and add the two together. That would work. That winds up being 2 integrations every time. Here's a neat little trick that I learned a few years ago. And if we use this for our formula, every time it's going to work. It's always the integral of the top function minus the bottom function. All right? Now let's look at why that works in this case here, okay? The top function is x cubed plus 4. Well, we know if we integrated x cubed, if we just integrated x cubed plus 4, we would find this area that I've got highlighted in red. Would you agree? Because that's what we just did. If we integrated the minus negative x, well, if we integrate negative x, what do we get? This area down here, but it would be negative because we've got a negative sign in there, right? By subtracting the negative, what does that do? That's going to make it positive. So if we simply use this formula every time, if we integrate the top function minus the bottom function, we're always going to get the right answer. Good morning, Connor.
Do we integrate them separately?
No, that's the nice thing. You can actually integrate them as one thing there, top minus bottom.
But you can't combine them before you...
Yes, you can. Yes, now you can combine them. If this were x cubed over here, we could add it and just integrate 2x cubed plus 4. We can combine. We can do anything algebraically that we need to do there. So if we integrate this from 0 to 2, we should get this entire area that we're talking about here. Let's see if we do. X to the 4th over 4 plus 4x. That's going to be plus x, so it's plus x squared over 2. And we're going to evaluate it at 0 and 2. Well, we know that's 16 over 4. We know that's 8. And this is 2 squared, which is 4 over 2, which is 2 minus 0 plus 0 plus 0. So we get 4 plus 8, we get 14. Yes, Chase, I see the wheels turning.
So I get why the top minus bottom works, but you could also do absolute value of one and the other.
Yes, you could do the absolute value of the first one plus the absolute value. You could do the absolute value of the top plus the absolute value of the bottom, and it would work out as well.
What if you did have negative on the bottom? Like, what if the curve, when it went around, ended up having it where it went below on the bottom, so it did have negative area? Like, if you integrated it, assuming y equals negative x, like you drew a curve.
Come draw what you want to draw. Because I think you're about 3 slides ahead of me here, but draw what you wanted to do there.
So if you had like a graph, and you were bounded by this, and then like a y equals negative x, and you had a curve like this, and then you had this area, this area, this area.
You're right. Now, you're
You can have
you're about 2 slides ahead of us. Yes, that's where we're fixing to head to there. Okay. All right. So, but boy, you're thinking ahead. You're on track there. Okay. Does everybody do you understand what we've talked about here so far? The big takeaway from you is you've got to integrate top minus bottom. Okay. Now, if you don't understand the concepts behind it yet, you're about in the same place of most students are at this point in the lecture here. But if you just remember top minus bottom, you're in good shape. We're going to work through several examples today and on Monday to kind of get this going, okay? So just remember, right now, it's top minus bottom. That's what we're thinking, top minus bottom. All right, so let's look at this next one that we've got up here. Find the area of the region bounded by the graphs of blah, blah. What's the problem? Or how is it different?
It's like this instead of that.
We didn't give you, before we gave you x equals this and x equals this as a starting and stopping place, right? So let's look at this. What area do you think we're talking about wanting to find here?
The top part.
The top part being what?
Like from 0 to the side.
All right. Come up here and color in what you're thinking about, Sarah Beth. Yeah, I understand you. Hey, that's very good. Okay, that's the region that she says that we're trying to find the area of. What do y'all think? Does that make sense? Okay, I agree. That makes sense. So we need to figure out what 2 points do we need for our limits of integration then? Anybody got? This one here and this one here, right? Y'all buy that? Well, Mary Martin, how can we find those other than just counting? Very good. We need to know where these two things intersect at, okay? Where they're equal to each other. So before we ever get to integration, we get to go back to do some algebra 2 or algebra 1. We get to say x equals 6 minus x squared. How do you solve that equation? Someone? Combine like terms. We don't have any like terms.
putting one side.
Yep. Let's get everything over to one side. So we'll say x squared plus x minus 6 equals 0. So what do you do now? That's right. We're going to factor this thing, okay? It's going to be x plus 3, x minus 2. So what does that tell me my x values are? Yeah, we've got -3 and +2. Okay? So we know we're going, and now if we go back and look at our graph, they coincide there. So we know we're integrating from -3 to +2. And if we just use our formula, top minus bottom, which function is top? So how do you know 6 minus x squared is on the top? Because we know it's a parabola, 6 minus x squared minus x dx. That's what we're integrating. 6 minus x squared minus x dx. Now, if you were doing, do you see how if you don't use the top minus bottom, if you were just trying to do absolute values, this really gets funky? Because you would have to find, if you were going to do this by not doing absolute values, I'm going to find this whole area by integrating that. Then I'm going to have to find this area and do what to this area and the big area I had? Subtract. And then find this area and add it back. Okay? So see, can it be done? Absolutely. It's not a problem to do it, but it's much easier if you just go ahead and stick this in there, top minus bottom. Okay? Crucial thing there. Another thing which some of you are not going to like very well, it is important that you have the capabilities of doing these on your calculator, because I can almost guarantee you that on the exam there's going to be one of these that you cannot do unless you can do it on your calculator. Okay, that's just been the pattern, that it has to be, that they are calculator activities. So the way I recommend doing these is I'm going to put the functions in separately. I'm going to put in the top function here, 6 minus, or I'm going to put in one of the functions here. It doesn't necessarily have to be the top one. Whoops, that's not what I wanted to do. 6 minus x, where's squared at? Squared. Then I'm going to put the bottom function on here, which was just x, right? Right. And now I'm going to integrate top minus bottom. How do I integrate top? Oh, this is how I'm going to integrate top minus bottom. Then I'm going to go in here to variables, y variables, function. It's y1 minus variables, y variables, y2. Now, I know that seems like a lot of work for you right now, that you're saying I could do all of that by hand. And you could, but you just wait until we get to the end of the month and we're finding volumes by rotating things. All of this is going to make your life much easier there, okay? So, for me, at this point in my math life for calculus, I'm probably going to have y1 minus y2. I'm just going to leave it in that y3 spot for the rest of the year because it's going to be crucial to have right there. So I would have those there, and then I'm going to be able to integrate using that. So how could I use my calculator now to find my points of intersection? Oh, I could integrate y3, but how do I know where from and to integrate it?
Oh, well, we have the values.
Yeah, we've got the values. Do you know how to find the values on your calculator? That's right. If I go right here to trace, whoops, not trace. I go to second calc, or just let it keep doing this thing. I'm going to go back to a standard window first. Zoom standard. And now if I go to second calc, I want to find the intersection. Now remember, we've got 3 functions in there, so we've got to be careful here, okay? 5. We want to find out where the first curve, 6 minus x squared, so we can press enter, intersects the second curve, y equals x. We don't want to do anything with the third one, so we want those 2 curves, and then we have to guess. We need to get close to where we think the point of intersection is, and it tells us at 2. And if we go through the same process close to -3, it would get that one for us. So we know what we're integrating now. So again, to integrate, we're going to go second calc, number 7. Which function do we want to integrate? Do we want to integrate 6 minus x squared? Nope. Do we want to integrate x? Nope. We want to integrate y1 minus y2. So we want to integrate that one. The lower limit's -3. The upper limit is 2. Oh, wow. Oh, we haven't done it. That's the reason why. We haven't done that one. Yeah. I was thinking about the last problem. I said, wait a minute, something's messed up here. But no, we haven't done this problem yet. And we'll get 20.833 or 20 and, what's that, 5, 6? No, 7, 12, something like that.
Why is Howard including the part below the line?
Good question. Why does this thing that is colored in not including that part below the line there? Anybody got any ideas?
Because the graph of the function minus the other function.
Right. Remember, we didn't integrate 6 minus x squared. We didn't integrate x. We integrated this. So that graph that you're seeing that's colored in is the graph of combining those 2 functions together. It's never going to give you the shaded region that we're trying to find there. Hello? Yes, ma'am, you can. Mr. West, your presence is needed in the upper school office there. So, is everybody clear on that? I know I'm beating this to death, but it's because it gets fun and exciting. See, here's what Mr. Dietrich was at a while ago. Look at this lovely, lovely, lovely graph. We have two functions, and they don't act nice. Sometimes the red one's on top, sometimes the blue one's on top. You need to be paying attention to me. Pokemon will wait. Okay? Sometimes the red one's on top, sometimes the blue one's on top. Well, what do you think we ought to do? Tell me what you think we ought to do, Sarah Beth. Sarah Beth says split them at 0. What do y'all think? Remember, our overarching thought is we're integrating top minus bottom. So, tell me what you need to do. Go ahead.
Would you do, kind of look at Sarah, so you stop at 0, but then you add it.
We're gonna integrate from wherever this is, which looks like -2, and we could actually figure that out. We probably need to. We'd integrate from -2. What's the top function from f minus g? How do we know that the top function is f? It's a cube, and we know it should look like that. So it'll be that integral plus the integral of what? 2 again. 0 to 2 of g minus f. Okay? Does everybody see that that's what you would do? All right, I have a question for you. What if you mess up? What if you were to, instead of integrating, you had a brain cramp for a second, and instead of integrating from -2 to 0 of f minus g, you integrated g minus f? Exactly. You'd get an answer that's negative. As soon as you're doing this and get an answer that's negative, you know you've messed up. How do you know you've messed up? That's right. We're looking for physical area on a piece of paper. It cannot be negative. So if you were to integrate this and get g minus f, you get -36. I don't know what it is. You know it's wrong. You know it's got to be 36. How do you correct that? You reverse it, okay? Now, here's a test-taking tip for you. You've got to be sure and reverse it on your paper, because when I'm grading this in June, or whoever's grading this is in June, if they see that you've got it written down incorrectly right here, even though you've got the right answer down here, you're not going to get full credit. So you need to go back and mark through this and make it the correct way there. Yes, sir? That's what I was about to say. If you want to do lazy, you just always do f minus g and know that you're going to take the absolute value bars afterwards, okay? So it's not wrong to do that, okay? A pure mathematician is going to look at you and scoff and say you're unintelligent. But it's not wrong to do that. Now, it is absolutely wrong if you go from -2 to 2 of f minus g. Does everybody understand what I mean by that? If you don't, you have to break it up into 2 or 3 or 4 regions, whatever it is. If you don't break it up, it's absolutely wrong, because it's not going to give you the right numbers there. But it's never wrong to put those absolute value bars in there. Okay, I'm not going to finish that off. You're intelligent enough to finish that off. You have the capabilities with your calculator to finish that off even. All right? Now, getting a little bit more, wow, I went crazy with these. Getting a little bit more away from holding your hands there. What are we looking at differently here?
There's no graph.
We don't have a graph, okay? you may want to sketch the graph of it in order to get a clearer picture. Do you have to? I'm not going to count off if you don't sketch the graph. I think it'll be sometimes it will be beneficial to you. But sketch the graph and find the area. Can anybody tell me what the integral is going to look like?
From 1 to 0.
Okay.
Negative, x squared minus 1 minus parentheses negative x plus 2.
Any questions about that?
Well, it works in this case, but we don't necessarily know over that interval they don't dip. We'd have to find intersections and take it.
Exactly. It would be wise to go back and graph this thing and be sure that this graph does what we think it does. Okay? So if I go back here and I put in x squared minus 1, and I put negative x plus 2, and I don't want... Do y'all know how to make it not graph 1 on here? If I move to the equal sign on Y3 and press enter, see that it's not highlighted, so it's not going to graph that. This will just graph me those two. And does it work for me? Do I need to know anything? It says from 0 to 2. Well, what's happening? Where are these two intersecting at? Do we know for sure where these two are intersecting at? Let's check and see where they're intersecting at. So we need to know second, trace the intersection of first curve, second curve, since we've only got... They intersect at 1.3. Does that help us or hurt us, or what does that mean, people? We want to integrate from 0 to 1. Yeah. So since we're integrating from 0 to 1, 1.3 is outside of that, right? Right. Exactly. Because if we integrate this as it's written right now, we're going to get a negative number, right? So we either need to put the absolute values on the outside, or we come back in here and put negative x plus 2 in front minus x squared minus 1. Now, if I were you and doing this by hand, I would definitely do some cleaning up algebraically here before I did this. I'm going to change this from 0 to 1 of negative x plus 2 plus 1 is plus 3 minus x squared dx. Then I will try to integrate it by hand. Whoops, it's 0 to 1, isn't it? All right, and if we do that, then we get negative x squared over 2 plus 3x minus x cubed over 3. Evaluated at 0 and 1. We know the 0 is going to be nothing for me, so I've got negative 1/2. A half has a 2 on it, doesn't it? Negative 1/2 plus 3 minus 1/3. So that's 3 minus 5/6. That's 2 1/6. That's 13/6. Okay? Is this complicated? Is this hard yet? Okay, because we're going to turn it on its side next week sometime. So it's kind of, or next week being Monday. It's important that you get a decent handle. Yes, sir?
I suppose.
Oh, I thought you asked me a question. All right. So, takeaways. Either on paper or on the calculator, you need to graph it to be sure you can figure out top minus bottom and be sure they don't flip anywhere in there, okay? And it's always top minus bottom, okay? Any questions? Now, you've got a little homework assignment due Monday night that you could go ahead and begin working on. You've got a web assignment due next Thursday. Again, you could probably work on that just a little bit, not a lot. So if I were you, well, not if I were you, you need to focus on the FRQ because I've got to get it graded this weekend because it's in the third quarter. So the 4 of you that haven't turned it in yet need to get it done, get it turned in to me so we can get it taken care of, and get started into the fourth quarter. By the way, during the fourth quarter,